Hi everyone, this is Mrs. J. Today we're going to learn how to find the surface area and volume of a cone. So we're going to start by talking about the properties of a cone. So a cone has a circular base and it has a single vertex. So you can see that this is just like an ice cream cone shape that you're familiar with. So the segment whose endpoints are the vertex and the center of your base is called the axis. And then here, this is sometimes the same as the axis, but it says the segment that has one endpoint at the vertex and is perpendicular to the base is the altitude. So for a right cone, as you see in this picture, the axis is going to be the same line as the altitude. So again, altitude, it must be perpendicular to the base, and for the axis, it must hit the center of the base. Also for a right cone, any segment that goes from the circumference of a circle, like here, to the vertex is called the slant height. So you can see that slant height here denoted with an L. So this is our height, also our axis, and this is our slant height. So the two formulas we're going to be working with are right here. First is the surface area formula. So the surface area can be found by finding the lateral area, and you can find the lateral area by doing pi times the radius times the slant height, and then you're going to add that to the area of the base, which is a circle, so it's pi r squared. And for a cone, the way you find a volume is by doing 1/3 times the area of the base times the height. And again, here you can see that the area of the base is just pi r squared because the base is a circle. All right, so let's see if we can try this first example where we'll be finding the surface area of the following cones. Okay, so remember for surface area, it's going to be that lateral surface, which is pi times the radius times the lateral height or the slant height, plus the area of the base, which will be pi r squared. So we do know our radius is 1.4, and we do know that slant height is 3.2. Notice this is our slant height right here, and this is our overall height. So we do want slant height for this formula. So now all we have to do is substitute the values. So we have pi times r, which is 1.4, times the slant height, which is 3.2, plus pi times 1.4 squared. So we can use our scientific calculator and we can use that pi button to get a good decimal approximation. Our surface area will be approximately 20.2 centimeters squared. Okay, in the second example, you'll see that here we are not given the radius, but we're actually given the diameter. So the first thing we can do is we can cut this diameter in half. So our radius is going to be 1.25. And then you can see that here, this denotes the total height. So that would go from the center to here. And remember, for surface area, we actually want the slant height. So we are going to need to find that slant height. So we can kind of make our own right triangle. Again, we know that this length is 1.25. We know that this length is 8. And then this is that slant height, which I'll denote with the L that we need to find. So we can find that, since this is a right angle, using the Pythagorean theorem. So again, this is 1.25. So we could say 1.25 squared plus this leg, which is 8. So 8 squared equals our slant height squared. So our slant height is going to be the square root of 1.25 squared plus 8 squared, which is approximately 8.1 inches. So now that we know both our radius and our slant height, we can now find the surface area. So remember, the surface area is going to be pi times the radius times the slant height plus pi times the radius squared. Again, we'll use our scientific calculator to get a decimal approximation. And we should end up with a surface area of approximately 36.7 inches squared. So just be careful when you're doing surface area. Make sure that you are using the slant height and not the height of the entire cone, because sometimes you are given the slant height and sometimes you're not. Okay, so let's look here at example 2, where we'll be finding the volume of the cones. Okay, so for this formula, we're going to be using volume equals 1/3 pi r squared times the height. So again, this time we want the height, not the slant height. So let's look at example A. Here we are given the radius, which is 5, and we have the height. I know it's the height because it is perpendicular to the base. So we have everything we need to find the volume. So here the volume is 1/3 times pi times 5 squared times 12. And again, let's get a decimal approximation in our scientific calculator. So here we should end up with a volume of approximately 314.2 inches cubed. Don't forget to cube your units whenever you're finding the volume. Okay, now let's look at part B, and here we're going to make sure to round it to the nearest hundredths instead of tenths. So again, we are given the radius, but here, this is our slant height, and for our volume formula, we want the height. So we do need to start by finding this value, this length. So again, we do have a right triangle, so we can find that height using the Pythagorean theorem. H squared plus 2.3 squared equals 6.5 squared. So if I subtract 2.3 squared and then take the square root, here's what I end up with. So this gives us a height of approximately, and we'll make sure to round to the nearest hundredths for all of our steps, 6.08 centimeters. So now we can find the volume. So the volume is going to be 1/3 times pi times our radius 2.3 squared times the height 6.08. So this gives us a volume of approximately 33.68 centimeters cubed. Okay, let's move down to example 3. So example 3 says, the figure represents a conical paper cup. How many fluid ounces of liquid can the cup hold? We're going to round our answer to the nearest tenth. So we are given the hint that 1 cubic inch can hold 0.554 fluid ounces. So strategy-wise here, we are going to want to start by finding the volume of this cone. So to do that, we do need to start by deducing what the radius is. So we are given a diameter of 2.2, which means that our radius is 1.1. And then for the volume formula, we also need to know the height, which is this perpendicular height. What we are given here is our slant height. So we're going to have to use this right triangle to help us find the height of our cone. So we can say h squared plus 1.1 squared. So remember, we're only using the radius for our triangle, equals 1.8 squared. So h is going to be the positive square root of 1.8 squared minus 1.1 squared. So here h is going to be approximately 1.4. And now we have the two pieces of information we need to find the volume of our cone. So our volume can be found by doing 1/3 times pi times our radius squared times the height. So we'll get a decimal approximation for that, rounded to the nearest tenth. So this gives us a volume of approximately 1.8 inches cubed. So now that we know how many cubic inches are in the cone, we can now use that to figure out how many fluid ounces that would hold. So let's set up a ratio. We know that 1 cubic inch can hold 0.554 fluid ounces. So that means that we can set up the ratio 1.8 goes with x. So here we can cross multiply and we'll get x equals 1.8 times 0.554. And actually, if you round your answer to the nearest tenth, you actually get 1.0 fluid ounces as your answer. Okay, so now we can move on to our last example, example 4. So here we're asked to find the volume of the composite figure, and we're going to round to the nearest cubic millimeter. So you can see here that we actually have a combination of a cone and a cylinder. So we can find the two separate volumes and then add them up. So let's start with our cone. We can see from the image that our diameter here and here is 16 millimeters. So that means that our radius is going to be 8. Now for the height, we see that the total height of the full figure is 32 millimeters, and we can see that the height of just the cylinder portion is 19. So if we do 32 minus 19, we get the height of just our cone, which would be 13 millimeters. So here, this is everything we need to find the volume of the cone. So we have 1/3 times pi times the radius squared times the height. And here we are asked to round to the nearest cubic millimeter. So in this step, I'm going to do that as well. So this gives us a volume of approximately 871 if I round to the nearest cubic millimeter, so millimeter cubed. So now we need to find the volume of the cylinder below. So I'm going to draw a quick picture of just the cylinder portion. So we know that the height of our cylinder is 19. And again, we know that our radius is 8. So remember, for the volume of a cylinder, we do the area of the base, which is pi r squared, and then we multiply it by the height. So very similar formula to the volume of a cone. So here we're going to do pi times 8 squared times the height, which is 19. And again, we'll round this to the nearest cubic millimeter. So pi times 8 squared times 19. And that will give us approximately 3,820 millimeters cubed. So that means that our total volume of the total, should be the sum of the two individual volumes. So it should be 871 plus 3,820, which gives us 4,691 millimeters cubed. Okay, that is all for today's video. Thank you so much for watching.